Okay, we're on topic 3.3, integration by substitution, question 2b. The integral of minus e to the power of root r over root r dr. First step, pick a u. So we're going to let u equals the square root of r. The next step is to differentiate your u, but remember differentiating square roots is difficult, so we write it as r to the power of a half. Now we're ready for our derivative, which is du dr. We bring our power down in front and then drop the power by 1, so I get minus a half. Now we know from the last question that's a half multiplied by, and r to the power of minus a half is 1 over r to the power of a half. Top by top, bottom by bottom, that's 1 over 2 times, and r to the power of a half is square root of r. So that's du dr. So we'll just write it again here, just to make it nice and clear. Du dr equals 1 over 2 root r. So I check if I have what I need. Well, I've definitely got a root r underneath the line here and a root r underneath the line here. And I have a dr here, which I know I'll get when I bring that over, but I don't want this 2. So I'm going to bring my dr over. And because this 2 is surplus, it's dividing where it is, so I'll bring it back over to my 2 du. So we'll double check now. I've got my root r underneath the line dr, root on r underneath the line dr. So that could all be substituted out for 2 du. So now I do my rewrite. Take out the things I don't need. I'll leave that minus outside. So it's e to the power of root r, but root r is u. So it's e to the power of u. Now, underneath the line, we've got a square root of r and a dr, but those are gone now because I can exchange them for the 2 du. So it's e to the power of u times 2 du. I like to have the 2 out in front myself. Okay, now we're ready to integrate. So we look up the integral of e to the power of x, or e to the power of u in this case, and you get back e to the power of u. Now we're ready to bring back in our u. So u is the square root of r. So I have minus 2 times e to the square root of r. And multiplying in, that's minus 2 times e to the square root of r, because we're at the end, plus c.